Just give me a second. All right, so we're now recording. All right, so last class we were looking at sine rule. And we looked at the special condition for sine rule, right? What was the condition that we must have for us to use the sine rule? Janice?
Yes, sir. Can you repeat, please?
What was the condition that we must have for us to use the sine rule? Trouble. Anyone can assist?
Sir, two angles, two sides.
All right, so we need two angles and two sides. And those angles and sides must correspond with each other. So two angles, two sides. And I'm going to put corresponding. I don't want to put corresponding angles because that's a type of angle. So two angles, two sides. Right, so let's say opposite to each other. So if we have a triangle, and what type of triangle do we use the sine rule with?
Any triangle that's not a right angle triangle.
Yes, so these are for non-right angled triangles. And do you know the name of these types of triangles? Do we know the name of a triangle that does not have a right angle? I'll take your silence as a no. So these are referred to as oblique triangle. So no right angles. All right, so let's say, so this is a quick recap before we move on to the cosine rule. So let's say this side of our triangle, I want one that works. I don't want one that is going to give us an error. All right, so let's say this is 21 degrees. This is 46. And so this would be B, A, C. And we want to find this side down here. So this is our unknown. Is it possible to find that side?
No.
Sure. Are you sure it's not possible?
Sir, didn't you say are we supposed to have two sides that form an angle that we know? Or
Yes,
if we're
so
gonna use so if we're gonna use it, we're supposed to have two angles on two sides, but only know one side.
so the angle, so in order for us to find side A, would need to know angle A, right? So my question to you now is, what property of a triangle do we know? What do we know about the angles in a triangle?
They all add up to give you 180.
So if this is 21, this is 46, what is this angle?
113.
113. All right, so knowing that this is 113, is it possible for us to find A?
Yes, sir.
All right, so how do we lay out our sine rule? What do we write?
A over sine A equal B
B, you sure you want to use B?
C.
Because we don't know what side B is, so it would be best
Yeah,
to use C here over sine
C.
C. All right, so let's,
Wait,
so
sir.
let's, yes.
If Sine is on the other side of B is easier by that angle. Like also sine using A. Using C, like it could be sine B
Yes,
or sine C.
yeah, we could find what this is
Okay.
using C.
Say put all of them together.
No, you'd have to do two at a time
Okay.
because that would be too many unknowns in one equation.
Alright.
All right, so we know that A is our unknown, so let's just write A over sine 113 is equal to, and C is 9 over sine 46. So we can transpose this sine 113 up there, and we will have A is equal to 9 sine 113 over sine 46. When you put that in your calculator, what do you get? Because I see some answers from the worksheet I sent, the interactive worksheet. Everybody answer read out. Just a few got the questions correct. When you run it off to one decimal place, can anyone else confirm? Can anyone else confirm this 11.5 centimeters? Kadeen?
Sir, I don't know.
You don't have your calculator out?
No.
Yes, sir, 11.5.
Okay, so Kadeen, get your calculator out. The next question will be for you. All right, so that's it for the sine rule. Any other questions on this? Because all we're doing is substituting. So we notice that whenever we're trying to find a missing side, we won't use sine inverse. But when we're trying to find a missing angle, so let's say we had a triangle like this. This is x. This is 72. This would be 12. and 5, something like that. And we're trying to find x. In this case, we would have to resort to sine inverse, because that's when we use the inverse of sine, when we're trying to find a missing angle. But when we're trying to find a missing side, we won't need to go to the inverse of sine. And remember, these are only used for non-right angled triangles, also known as oblique
So you can
triangles.
repeat that, please?
The part about the sine and
Yeah.
sine inverse.
Yeah.
So when trying to find, make a note. So when finding a missing side, we simplify. So if we're trying to find a missing side, we don't need to go to sine inverse. Only when we're finding the missing angle.
Okay, thank you, sir.
All right, so let's take a look at the cosine rule. Can anyone remind me what this states? What does the cosine rule state?
So x squared equals b squared plus c squared minus 2bc cos A.
Minus 2bc cos.
A.
All right, so I didn't mention this in class, but this cosine rule has 3 variations. And it all depends on, well, we could use this to find anything we want. However, to make our lives easier, there are 3 different variations of this cosine rule. So this is variation 1. Now variation 2, b squared is equal to a squared plus. So it's basically the same thing, but we're just starting with a different unknown or different variable. Minus 2 AC cos b. And we're going to see how these different variations work. And the third one would be c squared is equal to a squared plus b squared minus 2ab cos c. So that's the third variation. On the formula sheet, chances are you'll only see this variation. And if you want to find anything else, you would have to transpose. So now, what was the condition for us to use cosine rule? What was the condition?
Sir, as in like you only can use it with non-right triangle also?
Yes, but what else did we say about the sides and angles?
Sir, I don't really know that.
So
Sir,
this is,
can you repeat what you're
yes.
saying, please?
When do we use the cosine rule?
Is it the one that has to do like two? You have to know two sides and then form an angle
Well,
that you also know.
all right. So 2 sides and the included angle, or 3 sides. So 3 sides or 2 sides Alright, so let's look at how this works out. So we're going to do it with three different triangles to see how the three different variations can play out. Alright, so let's say we have this triangle here, A, B, and C. And let's say we were given all these sides. We were given side B, side A, and side C. And the examiner asks us to find this angle. So that would be angle C, right? We're finding angle C, correct?
Yes, sir.
Yes,
All right.
sir.
So which one of the variations do you think we're going to use if we want to find angle C?
So C squared equals A squared plus B squared minus da da da, all of that.
Yes. So that's the one that we will use. And the reason for that, seeing that this C is our unknown, once we substitute all the other values and transpose over on this side, all that would be left for us to do is to just cos inverse both sides, right? And get our C. So let me write it. So this would be C squared is equal to A squared plus B squared minus 2BC, 2AB, sorry, cos X. So let me just put in X there for now. And then once we know the values of these, all we would need to do is to just substitute and transpose, right? So this would become C squared minus A squared. So remember, you don't have to do this part of it. All you need to do is to just plug in the values and simplify. I'm just showing you what the transposed version would look like. Is equal to negative 2AB cos X. And then we would divide. So that's, we divide both sides by negative 2AB. So that will cancel. So our final answer will be cos inverse of C squared minus A squared plus B over, and that would give us X. So that's what a transposed version of this would look like. But as I've stated, all you need to do is to just plug in the values, evaluate, and then transpose. So this is the variation where we're trying to find C, and if we're trying to find angle B here, we'd use the B variation. If we're trying to find angle A, we'd use the A variation. Everyone clear?
Yes, sir.
Yes, sir.
So let's look at if we're given two sides and our included angle. Alright, so we have our triangle here, A, B, C. And if they gave us side A and side B, and they tell us that angle C here measures 30 degrees, and they want us to find side C. This is the unknown. Now this would make our lives very easy because what we can do is we can just use the C formula, right? Because we're trying to find side C. So we could say C squared is equal to A squared plus B squared minus 2AB cos C. And a question like this would be beautiful because you would already know side A, you'd know side B, and you'd know the angle C. So all you would need to do is substitute all of that in this side of the equation to get C squared. And after doing that, you just find the square root of both sides to get your C. Pretty simple, right?
Sir, hold on.
Yes.
You see, a question like this, we would already know A and B. Like, if we got the values for those, we would already know them. That's what you mean, right?
Yes, because for a question like this, for two sides and the included angle, this is
Okay.
what it would look like.
Okay, sir. Thank you.
So I'm going to give you one to try. So I'm going to give you one to try. I'll give you two, one with the included angle and one with all three sides. And after this, we'll look at the area of a triangle formula using the half AB sine C formula. Alright, so try these questions. So this is question 1. You're given a triangle. So for these questions, you don't need more than 4 minutes per question. Alright, Amia?
Whatever you say, sir.
Alright, so this is 35 degrees, 9 centimeters, A, 7 centimeters. So find what A is in this case. And for this one, X. So X right here is our unknown. I know you're going to say you didn't get a variation with X, but it's pretty much the same thing. Just the letters change, but it's the same thing. Alright, so try these questions. I'm giving you until 1 o'clock. Then we'll go through the solutions for these. So the first question will be for Kadeen, and the second question is open to anyone who is willing to try. So you have 2 minutes. All right, Kadeen, you're up. Which variation of the cosine formula do we use?
The a square equal b square plus c square.
What else?
Minus 2 bc b something
What goes here?
cos a
All right, so let's substitute the values. So that's 9 squared plus 7 squared minus 2, 9, 7 cos 35. Right, so when you do all of that, what do we get? or you did it piece by piece. So that's 81 plus 49 minus 126. So a squared is equal to, alright, someone work that out for me.
Sir, 1.8. Oh, no, no,
Yeah.
no. 3.276608177.
When you put all of this at once,
Mm-hmm.
that sounds like
Sure,
26.
26.78.
Because
5.17. They would find the square root at 26.79.
Yeah, what you want to talk about after the equal sign?
so this is 130 take away 103.
Cos 35.
Say it's what, 26.78.
26.78.
Alright, so we need to take the square root of both sides, and
Which
a
is
would be equal to
5.176.
5.18. So that's 5.18. Alright, very good. So that's how we apply the cosine rule when we're given two sides and an angle between those sides. So how do we find our missing x over here when we're given three sides of our triangle? Who is going to take this one? No volunteer? Alright, so let's see who is here. Alright, so Carlisian. So we're looking at this triangle and we want to find x. And what did she say is alright, so Carlisian has raised. Go ahead, Carlisian. Or in the interest of time, if anyone has the solution to this one, just give me your answer here. Which variation can we use? Or how do we write or set out this question? Nobody did this one?
Sir, x squared equal y squared plus z squared minus 2yz cos x.
And why did you start with x squared?
Because we're trying to find cos x. We're trying to find x.
Yes, so x is a missing angle. So whatever is missing, that's what we start with and end with. So like this one, A was missing, so we start with A and we ended up with A over here. So just pay attention to that. It's very important that you know which or how to set out this formula. All right, so let's plug in our values. So that's 10 squared is equal to 14 squared plus 8 squared minus 2, 8, 14 cos x. So that's 100 is equal to 196, 64 minus 196, 210, 224 cos x. 224, right? 2 times 8 times 14. So that's 100 is equal to 264 minus 224 cos x. 100 minus 264 is equal to negative 224 cos x. Divide both sides by negative 224. That's going to leave us with, so this is negative 164 over 224 negative. So x would be equal to the cos inverse of 164 over 224. And what do we get when we evaluate that?
Sorry,
42.9.
42.9.
42.9 degrees. And all of this is just substituting and transposition. The most important part of this question is figuring out which variation or how to set out the formula. Once you're able to set out the formula, basically the answer is in the palm of your hands. So any questions about cosine rule? If we don't have any questions, we'll move on to area of a triangle or non-right angle.
I have a question.
Go ahead.
I don't understand. I come late.
Eh?
Sir, that is not a question.
Exactly.
Don't talk.
All right. What I will do is, well, there will be a recording, so that will be shared because we need to start bearings at least. So the recording will be shared with you. All right. So next we move on to area of non. So area of non-right angle triangles, and this one is fairly simple. What was the formula for this again?
Sir, half AB sin C.
What is it?
Half AB sin C.
Okay, half AB sine C. And for this one, what was the characteristics of this one? So for this one, you need to know two lengths and this the angle between those lengths. So two lengths or two sides and the angle between. So these are referred to as, well, this one in particular is referred to as the side angle side formula. And the cosine rule would be side 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 or side angle side. But we won't get into that. That's not of that great importance. Alright, so let's just do a quick example of this one. This one is fairly simple. So we're given a triangle here. And this is our A, B, C. So let's say we were told that this side measures 15 centimeters, 17 centimeters, and this angle here is 42 degrees. We're required to find the area of this triangle. So all we would need to do, as long as it satisfies the condition where we have two sides and the angle between, we can apply our formula. So the area would be equal to half, and A is 15. Well, in this case, it would be half AC sine B, right? Because we know side C and we know side A. So it has to be half AC sine B. And what you will notice about these formulas is that they aren't specific to one type of triangle. The triangle can be labeled anyhow. It's just you have to be able to reason out or look at the different variations of that triangle. So this would be 17 and sine 42. So when we put that in our calculator, what do we get? So 15 times 17 divided by 2, that's 127.5 sine 42. Yes?
85.3.
So 85.3. And what's the unit?
Centimeter squared.
Centimeters square. So for this one, it's pretty basic, pretty self-explanatory. Nothing too technical about this one. All right. So any questions about this one? Or you want one to try? All right, so I'm hearing Deja saying yes. So I'll
So
give you
it's not
one.
good to lie. So it's not good to lie.
I thought Deja said yes.
Okay.
All right, try this one on behalf of Deja. So find the area of the triangle. So this is A. So I'm giving you 3 minutes for this one. start bearings. One minute. All right, so can I have a volunteer for this one? I want to find the area of this triangle. So how do we set out our formula? All right, I guess I'm going to have to start calling names. Um, let's see. Ashar, this question has your name written all over it.
Yes, sir.
This question is yours. Want to find the area of this triangle. We're given two sides and an angle between. So walk me through what I should write.
Sir, is it the something with the half? The Is
Yes,
it the half
Ashar.
base?
No,
Half
not half
in?
base.
Oh.
What we just did around here.
So would that be half times 7 or the 12?
So half times 7 or the 12.
And no, right, 12, 12, sir.
What else?
And then sin 70,
Sine
40, sine, sorry, sine 77.
77. So when we work this out,
So I don't have a calculator.
so 7 times 12, that's 84, divided by 2, 42. All right, so what do we get when we put this on our calculator?
40.9
40.9
And what's the unit?
centimeters squared.
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 Centimeters squared.
Oh, someone just said squared.
Because already is a centimeter.
All right, so this would be the area of this triangle, and that's how we approach questions like these. So any question on this one? And everyone can see the well, I share the document titled All Things Trig. What I would advise is for you to go through that document. Your next class work questions will be pulled from that document. All the questions on your classwork will be from that document. So go through and ensure you understand. If you don't understand, just ask your questions. Alright, so last thing on our agenda for today, this is just an introduction to bearings. Tomorrow when we meet, we'll go through some examples of questions like these. Alright, so bearings. First time hearing the word?
No,
Geo
sir.
students,
No, sir.
what are bearings?
Sir, is it
To show where you are on the map.
Show where you are.
sir, direction? Sir, like coordinates?
Alright, so direction coordinates. So yes, you are both correct. Bearings are a measure of direction. And what's one thing we always use when working with bearings? Is this
Sir, compass.
Degrees.
Alright, so we use degrees, we use compass. Um, you are both correct. So there are special characteristics to bearings. Bearings always use the north line as our reference. So let me write bearings So north is always taken as our reference. Another thing to note about bearings, who knows which direction we measure bearings? What direction do we measure bearings from? Or in?
So is it north?
Well, we use the north line, yes, but direction. Which direction are we going when we're measuring our bearings?
right?
Clockwise.
Yes, in a clockwise direction. So bearings, and one other important thing about bearings is that they are usually um, represented using 3 digits. So bearings. So these are the 3 important things you need to know. There's a measure of direction with north taken as reference. They are measured in a clockwise direction from the north line, and bearings are given or read as 3 digits. So 3 digits. All right, so let's say we had an angle, or we had our north line here. So this is our north line. This is 90 degrees. This is O. So what if, or if I were to ask you a question, what is the bearing from the north line to this horizontal line? What would you tell me? What's the bearing?
Sir, can you repeat the question,
The
please?
bearing between here, the north line,
What would it be 090?
so 090 degrees.
90?
So it's 90, yes, but remember we have to represent it using 3 digits. So it has to be 090, and you put your degree sign.
Question, sir. So, sir, if the measurement is 2 digits, you have to put a zero before it.
Yes, even if it's 1 digit, you put two.
Two
So it
zeros.
will be 003 degrees.
Okay.
So it's always 3 digits. All right, so let's look at an example here. We're almost out of time, so tomorrow we'll have to go into the technical questions. All right, so let's say we had point A, point B, and we want to find the bearing from point A to point B. So bearing and some keywords you should look for whenever you're given a question like this: from and to. So if it says from point A, that means point A is our starting point, correct?
Yes, sir.
And to point B would be our end point. So this is how we make note of the bearing. So the first thing we need to do is make a connection between those points. So that's the connection between point A and point B, right? That's the first thing we do. Make a connection. Next, from the starting point, we need to put our north line. Always remember your north line. So that's our north line right there. So now, to get the bearing, and remember the bearing is just an angle, right? So to get our bearing, we can just put our pencil on our north line and move in a clockwise direction until we touch the line that connects both points. Everyone saw what I did there?
Yes, sir. So the circle not like the proper.
Repeat.
Never mind.
So whatever angle this works out to be, this will be our bearing. So tomorrow we'll look at how we can work out those, because they would have to give you an angle here or a distance or something else to work it out. All right, so
Okay,
let's,
sir. Excuse me.
yes,
Is tomorrow online or face to face?
face to face.
Okay.
All right, so let's say we had another example here. We had point A and point B,
Oh,
and we wanted to find the bearing from point A to point B. What's the first thing we do? Let's see who has been paying attention.
Sir, draw the north line.
That's the first thing we do.
sir, connect it.
Connect them first.
Connect the points. That's the first thing. What's next?
Figure out where you're coming from and draw the north line.
So where are we coming from?
From A to B.
We're coming from A to B. Which point are we starting?
So are we using the same thing up at the top that said bearing from point A to point B?
Mm-hmm. Yes.
You say you're coming from A,
All right, so
going
we're
to B.
starting at point A. So we do our north line here. So that's our north line. What next?
Say, you draw the circle from the north line, come around clockwise.
Circle.
The yeah, you know me talk.
So you draw an angle starting from the north line, and then you stop whenever it touches the line connecting both. So this would represent the bearing. All right, so this is just how we um, represent these types of questions. So tomorrow we will look at some actual numbers with these questions. So that's it for today. So I'll send the recording as soon as it's finished processing. All right.
Okay,
Yes,
sir.
sir.
All right. So and I'll also send the notes from this document.
Okay, sir.
All right. Take care.
Bye.
Mm-hmm.